Polyominoes are shapes that are created by putting squares together in such a way that the edges of the squares sort of are shared. So for instance, your most basic polyomino using two squares would look like that. If you have more squares, for instance 3 squares, you can make something like that, or something like that. In general, these are called polyominoes, but when it's 3 squares, we call it triominoes, and 2, or sometimes we just say 3 ominoes. With 2, we can call it a 2-omino, or a domino. Of course, the game dominoes are played with pieces that are rectangles created by 2 squares. Now, the number of triominoes that I can make, it depends if you count, do you count the sideways one as a new one, or is it equivalent to this one over here? And we'll say that no, a rotation does not count as a new one, and because of that, we actually can't make, these are the only 2 triominoes that can be made. We can make only 1 domino, and we can make 2 different triominoes. Any other triomino you try to make is going to be either a rotation or a reflection of these 2 that already exist. When you go to 4 squares, they're called Tetrominoes, and the game Tetris is based on these because if you look in Tetris, the pieces are all tetrominoes. Now, officially, these are the only 5 tetrominoes, although in the game Tetris, because the way the game is played, you can rotate pieces, but you can't reflect them. So in the game Tetris, they actually have they have 2 more pieces. They have this one, even though this is actually equivalent to the one above it. In the game Tetris, you can't get it. You need to reflect, which is not an option. And they also have this guy being reflected. So in the game Tetris there are 7 pieces, but we say there's only officially 5 tetrominoes. A challenge that we did in class was to come up with all of the pentominoes. There were about 35 of them, or there were 35 of them. And some of the challenges are, is there a way, let's say I have a tetromino, maybe 4 squares, how could I make a pentomino out of that? Well, I could maybe stick my 5th square here, or maybe I could stick my 5th square here, or maybe I could stick my 5th square down here, and I get different pentominoes. So, a challenge, some questions you might wonder is there a way to create all the pentominoes if I have the 5 tetrominoes to somehow build on them? And another question is there a formula for saying, okay, what if there's 6 squares? Oops, I said something wrong. Just realized there's actually only 12 pentominoes, but hexominoes, which is 6 squares, has 35 of them. So a challenge is, can you make the 12 pentominoes, and is there some sort of formula or some sort of process for creating them from knowing all the ones of the small number of squares? And then another question is there a way to determine how many, like pentominoes, there were going to be, or how many hexamonos? There is not a real nice formula for that second question, but it's an interesting challenge, and hopefully it's thought-provoking to you. Here is a picture of the 12 pentominoes, and sometimes they arrange them so they rotate them or flip them so they look like letters, so that they can be described more easily. So those are the 12 pentominoes.